stem, monocot stem. Okay, so it would be quite easy. We'll begin with anatomy of the monocot stem. What you notice in the ground plan, as I already told you, ground plan is very important, and as well as the enlarged section. Okay. So in the ground plan, you can notice that there is a dotted line. Can you see this? This is nothing but cuticle layer. Outermost cuticle layer is there. The first layer is nothing but the epidermal cells. Single layered barrel shaped cells are there, epidermal cells. Okay. Inner to that you have this hypodermis. Hypodermis is made up of collenchyma type of cells. And what you can notice is there is no cortex and stele. Instead we call it as ground tissue. You cannot demarcate between cortex and stele. Instead we call it as ground tissue. In this ground tissue you can find many vascular bundles are scattered. There is no definite pattern of arrangement. It is not ring-like or anything. It is scattered. So we call such type of stele as attactostele. What do we call such type of stele as? Attactostele. This is unique in case of monocotyledonous plants. When you take a section of monocotyledonous stem, what you notice is there is no clear demarcation between cortex and stele. Instead we call it as ground tissue. In this ground tissue, there are a lot of vascular bundles which are scattered. There is no definite pattern of arrangement, they are scattered. Such type of stele, what do you call it as? Attactostele. Now when you come to this vascular bundle, I am not using the word stele, I am using the term vascular bundle. What do you notice? Xylem and phloem are together. What is that condition called as? Conjoined. Okay, so there is conjoined collateral. Xylem is towards the pit, phloem is towards the external side, collateral, conjoined collateral, closed. What do you mean by closed? There is no cambium, there is no secondary growth. So if the vascular bundle does not have cambium, what do you call it as? Closed vascular bundle. Conjoined, collateral, closed, endark. Why is it called as endark? Because what you have to notice is protoxylem is towards the center, metaxylem is towards the periphery. Protoxylem is towards the center and metaxylem is towards the periphery. So that is what you have to remember regarding this ground plan of it. So in the ground plan, what were you able to notice? An outermost cuticle layer, then an outermost layer of epidermal cells. Okay, inner to that is the hypodermis. The first layer of cortex is hypodermis, which is made up of collenchymatous cells. And then you find there is no difference between cortex and stele. They don't have endodermis, they don't have pericycle. So rather we call this tissue as ground tissue. In the ground tissue you find a large number of vascular bundles are scattered. So such an arrangement of vascular bundles, if they are scattered, what do you call them as? Attactostele. That condition is called as attactostele. Now when you study the vascular bundle individually, you notice that they are conjoined. Why are they conjoined? Xylem and phloem are present in a single patch. They are not present separately in separate radii as it was in case of root. They are present together, conjoined. They are present together, joined together. Okay, collateral. Xylem is towards the center, phloem is towards the periphery. Closed type of vascular bundle because they do not have cambium. And why do we call it as endark? Protoxylem is towards the center, metaxylem is towards the periphery. So we consider this condition as endark condition. So these are the important points that you have to remember when you are describing the vascular bundle. How will you identify? How does it look? For you, how does it look? This one. Face iddange. For some of you it looks like skull. For some of you it looks like joker. You can see the same thing even in your slide, permanent slide survey. You notice these things immediately. You can identify that as monocot stem. scattered vascular bundles. And they also, if you join them, how does it look? It looks like alphabet Y. It looks like skull shape or a joker shaped face, or it also the arrangement of xylem is in almost Y-shaped arrangement. Okay. So what you can notice, protoxylem is towards the center, metaxylem is towards the periphery. Some of the protoxylem are crushed. Some of the protoxylem are crushed and they store water. Some of the protoxylem are crushed and they store water, which we call it as lysigenous cavity. What do we call this as? Water containing cavity as lysigenous cavity. They are formed by the crushing of protoxylem elements. See, here they have enlarged it. So you can see the metaxylem towards the periphery, protoxylem towards the center. And this mouth-like structure cavity, it is having water-filled cavities. How is this? This is also called as lysigenous cavity. How is it formed? By the crushing up of protoxylem elements. So this is what you have to notice. Now in an enlarged section, cellular details, they have an outermost thick layer of cuticle. Then they have epidermis. Hypodermis is made up of colon-chyma types of cells. Okay. Then within the vascular bundles, these are sclerenchyma. Okay. Apart from xylem and phloem, they also are, instead of parenchyma, they are enclosed by sclerenchymatous tissue. Then you can notice the phloem. Phloem with sieve, tube, companion cell, phloem parenchyma, phloem fibers. All these are noticed in phloem. The green tissue is the phloem. Then you have xylem. Metaxylem towards the outside, protoxylem towards the inside. Endar condition. This water containing cavity, which is nothing but lysigenous cavity. They are formed by the crushing up of protoxylem. Okay, then xylem parenchyma. This we call it as ground tissue. You know that we don't use the term cortex and endodermis pericycle. We don't use such terms. Or steel, we don't use such terms. Instead, we use the term as ground tissue. They are homogeneous tissue. We call them as ground tissue. That is what you have to remember about monocot stem. They are having scattered type of vascular bundles, that is called as adactostele. The vascular bundle is conjoined, collateral, closed and endar type. Why is it closed? Because cambium is not there. If cambium is not there is no secondary growth in monocot stem. That you should remember about. Now we go for the next one, very important, that is the transverse section of a dicot stem, anatomy of dicot stem. Here the example that we have taken is Helianthus annulus. What was the example for monocot? Zea mays or maize. So what you can notice in this particular diagram is, this is the ground plan of dicot stem. They are having an outermost layer, epidermal cells, they have a thick layer of cuticle. Cuticle is also there. Apart from that, from some of the epidermal cells, a multicellular hair structures are formed, which we call it as trichome. A multicellular hair structures are formed, which we call it as trichome. Then this is the cortex region. Cortex is, you find an hypodermis, central layer of parenchymatous, chlorenchymatous cells, one layer of chlorenchymatous and parenchymatous cell. So there is outer cortex, middle cortex, inner cortex in case of cortex. And what you have to remember is, here you find steel structure. There is an outermost layer of endodermis. But endodermis is not circular, it is wavy mannered. And endodermis has starch granules distributed in them. So we call it as endodermoid layer. Instead of endodermis, what do we call it as? Endodermoid layer, because they have starch granules distributed in them. Okay. Next layer after the endodermis is the pericycle. Okay. And this bulb-like structures, what you find, ciliary bulb, they are all vascular bundles. How are the vascular bundles arranged? In a ring-like manner. Even though it is wavy, it is a ring-like manner. So this type of steel in dicot stem, we call it as U steel. What do we call it as? U steel, Vijwananta steel. Where the vascular bundles are arranged in a ring-like manner. Now let us see the enlarged section of this dicot stem. The outermost layer is epidermis, they have a cuticle layer. Okay. Then they have stem hair, which is multicellular. It is not unicellular, it is multicellular. We can also call it as trichome, stem hair or trichome. Okay. Then the cortical layer is there, where I told you the outermost layer you find it as the parenchymatous. The central chlorenchyma is there. Inner parenchyma is there. Three layers you can notice in the cortex. Outermost parenchymatous, middle cortex is a single layer of chlorenchyma, and innermost is normal parenchyma cells. So that is what you can notice in the cortex. Now the cortex, immediately after the cortex, the innermost layer of cortex is endodermis. Since they have starch granules distributed in them, we also call it as endodermoid layer. So endodermis has Casparian thickenings. There is no other things that you have to remember about, like passage cell and other things you will not worry about, because stem is not involved in absorption of water. You have to understand that. So there is an endodermoid layer. Then there is pericycle. Pericycle is sclerenchymatous, more than one layer. You can notice this. This is the pericycle. They are made up of sclerenchyma, dead tissue. Okay. Then the vascular bundle. What type of vascular bundle it is? Conjoined, collateral, open or closed? Open, endar. Conjoined, collateral, open and endar. Conjoined because xylem and phloem are present in a single patch. Collateral because xylem is towards the pair, phloem is towards the periphery or towards the endodermal layer. Okay. Then why is it open type? Because can you see this brick-like cells, many layered cells, cambium. Cambium is present, so we call this vascular bundle as open type of vascular bundle. They will undergo secondary growth. The girth or diameter of the stem increases in dicot because of that cambium. The innermost layer is the parenchyma. Why do we call it as endar? Please look into the protoxylem. Protoxylem is towards the pith. Metaxylem is towards the periphery. Metaxylem is towards the periphery. That's the reason we call it as endar condition. You can notice that even in monocot stem. Okay. So these are the two things that you have to remember about. So what we discussed about the monocot stem, what do you call the stele in monocot stem as? Attacto stele. How do you describe the vascular bundle in monocot stem? We describe it as conjoined, collateral, closed and endar type. How do you describe the stele in case of dicot stem? U-stele. Stele is U-stele because they have the vascular bundles arranged in a ring-like manner. And how do you describe the vascular bundle as? Conjoined, collateral, open and endar type. Okay, so these are the things that you have to remember regarding the anatomy of monocot stem in case of Zea mays, maize plant, anatomy of dicot stem in case of Helianthus annulus, sunflower. So remember about these details. Have you understood about it?